Good afternoon, good evening, or good morning from wherever you're joining us from today. My name's Sarah and I'm the Program and Event Manager at the Reactor in Sydney, Australia. Welcome to another Microsoft Reactor Sydney live stream event and an episode of our Devs Down Under series. I'd like to welcome today, joining us for the first time, is Jorge Arteiro. So Jorge is a cloud developer advocate for containers based in Melbourne, Australia. He has over 20 years experience in the tech industry. Also, as a former Microsoft MVP, he developed a passion to help and sponsor the community to get into the tech industry and to help them to collaborate and share their own knowledge with others. Today, he'll be showing you how to manage your Kubernetes clusters with Cluster API, Azure Arc, and GitOps. You will see today I have put a check-in link in the comments section with the event code 14269. Can you please check in for today's session where you'll find additional resources, and Jorge has kindly shared his presentation with all the resources as well that he's provided. So you can find that when you check in. So we will be speaking today for about 40 to 45 minutes and hopefully with some time for questions at the end. However, do send us your questions throughout, and between Jorge and myself, we will have a look at those questions coming through and try and answer as many as possible. At the conclusion of the session, we'll also share with you a link to our feedback survey. If you could fill that out with the same event code 14269, that would be great. And if there's anything that you missed from today's session, there will be an on-demand version available straight after today on our YouTube channel, which I'll share with you in the comment section throughout today. But for now, I'll hand the floor over to Jorge to begin. So thank you, Jorge, and over to you.
Thank you, Sarah. Appreciate. Welcome everyone that's watching this session. If you're watching the recording and you need help, let me know. Like Sarah said, my name is Jorge Arteiro. I just 2 months ago joined the Cloud Developer Advocate team on the container cloud native side. And I come from consulting. I live in Melbourne, Australia. Then I've been doing that for more than 20 years, coming from Linux, coming from .NET development, and 5-6 years ago started on that Kubernetes migration, let's say, or new technology. And then I joined that boat, and that's where I am today. Let me go here for my presentation. The whole idea today is go through what we call Kubernetes Cluster API. And my agenda today is getting like a idea how we can use that in a real customer scenario. Then we go to understand how we can use Azure Arc to help with fixing this problem. That's the problem is managing multiple Kubernetes clusters running anywhere, not just on Azure, but other clouds. What kind of technology and how Cluster API can help with that. And then we're going for Cluster API itself, understand the fundamentals, the Azure provider for Cluster API, and we're going for hands-on demo. That's where I'm trying to spend most of my time. And let's see, 45, 50 minutes, we get through this. Before I start, I would like to ask you to join that new community that was created last year. May last year, we have almost now 800 subscribers. We have a blog and have a Twitter account as well. There are most like 80 videos at the moment. There's a few coming. Then hit the subscribe button on YouTube and follow us on Twitter. There are content most in English, but there are content in Portuguese as well. And I'll be doing this same talk next month at the Reactor in São Paulo in Portuguese, if you are interested in another language. Or let someone in Brazil know as well. Then let's bring like a real case, scenario to understand the problem here. Imagine that we have retail customer that they're looking to move all the applications to use containers, to use Kubernetes, probably microservice, more cloud native way, but they are spread across the globe. And now they have a problem. They need to manage those Kubernetes clusters anywhere. That could be on-premise, that could be on Azure, that could be someone else. And they facing this problem. How can do the same way, in a uniform way, deploy, configure, and manage those clusters? And the requirements are very simple. They want to bootstrap those clusters the same way to enable, the technology team, the IT team to manage those clusters and have the same way to do monitoring, governance, to deploy the applications, to apply security, governance as well, and deployment and safe deployment. How we can do that the same way across the globe using, and that's the problem, that's the challenge. How I want to introduce one thing that can help us to solve this problem. Okay, how Azure Arc, I'm not talking here the whole Azure Arc, I'm just going to talk about Azure Arc enable Kubernetes. Is a part of Azure Arc. Azure Arc is bigger than just enable Kubernetes, but let's go to understand what that is. As Azure Arc is a single plane, like a single control plane or a single plane of glass for you to manage resource, being those resources be on Azure or be someone else, somewhere that we can manage like data centers on-premise, on the edge, or even on third-party clouds. How can we, from a single control plane, manage those things? I'm not going to discuss all those services available on Azure Arc. Like I said, we're going to focus only on Kubernetes. But keep in mind that you can do SQL database, we can do now web service, that will be platform as a service from Azure now can run on-premise, can run in other clouds. And by the way, those things runs on top of Kubernetes. Then Kubernetes is a base that we need for the other things to come and be deployed. That's why Kubernetes enable and what we call connected Kubernetes on Azure Arc is so important. And enables multi-cloud as well. How that works? The same way is we're now going to have that consistent thing, and the hybrid multi-cloud that I was talking about could be VMware, AWS, Google Cloud, Azure, or even Azure Stack. And we're going to focus here again on Kubernetes. We're not going to discuss the other things. What we have on Azure Arc for Kubernetes, let's say I create a cluster on-premise, or I create a cluster using OpenShift or GKE or EKS or even Azure, but not the managed service. And I want to manage those clusters from Azure Arc. What do? We connect those clusters. We connect those clusters outside to the Azure Arc, is like that control plane, that dashboard. That's going to give you something, going to give you extra management and that governance that the business are asking for, the requirements that our scenario is asking for. Then once we connect, now we can use something on Azure called GitOps. Okay, we're going to see what GitOps is. And GitOps is going to enforce a state of my application on those clusters without having to do like pipelines or anything. We're going to use the Git repo, and the cluster itself is going to deploy these applications. That's what GitOps is. We're going to see in details. The same for monitoring. We can enable integration with Azure Monitoring. Then now we're going to export all those metrics, all these logs to Azure, and you're going to be able to operate the same way that you manage it like AKS. That's a fully managed service. You're going to operate all those kind of service, third-party ones, anywhere, even on-premise, the same way. And same apply for security and governance. On the security, we have something on Azure called Azure Policies. With one thing in Kubernetes called Open Policy Agent, we are able to apply those Azure policies on Kubernetes clusters. And we be able to have governance the same way that we have on Azure resource, on resource running anywhere. By the way, monitoring and governance and security works as well for servers, for database, not just for Kubernetes. My focus today is be Kubernetes, but keep in mind, works for other things. And now we have this. Now we can have all these clusters running anywhere, but with monitoring and security the same way. And monitoring and security is one thing that we call extensions. When you connect one cluster from outside to Azure Arc, you are able to install extensions. And monitoring and security are kind of extensions. Then once we install and you enable those extensions, you're able to use those policies and the native Azure monitoring for containers. And the connected Kubernetes on Azure Arc also enable integration with Azure Active Directory. And they also enable Cluster Connect. Cluster Connect is kind of a firewall where you don't have to open your cluster that's running, like, say, on-premise, on your data center, on another cloud. You don't have to open that for Azure. There's a reverse proxy where you don't have to have this connection open. The cluster itself, there's an agent that's going to call Azure and ask for any connection if someone want to connect. Kind of a firewall there. But it's all implemented by that Azure Arc feature. And cluster location is nothing more than allowing you to create a location that's outside Azure that you're going to be able to deploy your app service like Logic Apps, Azure Function, Event Grid. You can also do API management engine. You can run on anywhere. Once we enable cluster locations, you're going to enable agents. That's in preview, but it's going to be public preview, I think. Is in public preview, but it's going to take some time for GA, but keep in mind that now you can deploy Azure Platform as a Service on Kubernetes anywhere. Then we go back for our example, for our scenario, and say, what's the benefit of using Azure Arc to do that? The first thing, I think the most important will be the GitOps there. Means that once we have those clusters created, okay, you maybe have a way to do all those clusters, you create all those clusters, but now Azure Arc is going to say, once those clusters be deployed, they're going to go on the Git repo and they get your application deployed, and you don't have to do anything. Once that application changed, someone merged like a commit on that Git repo, that is going to be applied on all those clusters. Then now we avoid one problem, that's security. We now don't need like pipelines with agents, with credentials to connect those clusters to deploy the applications. And that's a big challenge, because imagine managing credentials for all those clusters in different places, in different technologies. Now we can say, no, the cluster itself is going in a single place. That's a Git repository. And they're going to be able, using like a Flux operator that you're going to see, that's like a piece of software running inside your cluster that has the power to deploy the application. Okay, that's a big one. The second one, you have Azure Portal, like a dashboard where you can manage all those clusters in a single place, a single pane of glass, in a single dashboard. Application deployment, we talk using GitOps, and the same way you're going to manage the source control for those applications using Git. And we're not going to, you're going to be able to use any tool that you want on that solution. You're not going to be restricted to, the developer tool that you want to use. You can keep using any developer tool like Helm, Customize, or even, YAML files. You can keep using the same way. Okay, they're going to support that. But now I have a problem. Like, we can use Azure Arc to automate, Active Directory, monitoring, GitOps deployment. But we still have one thing there. How are we going to deploy those clusters? We are assuming that the cluster is already created. Azure Arc is assuming that the cluster is created. And you're going just to connect this cluster to Azure Arc. And then you have all those things available. But now I have a problem. We have to create those clusters anywhere. Okay, how we do that? And that's where, by the way, where Cluster API is going to come. How to create those clusters. Just before I go there, I want to go a little bit deeper on GitOps, because GitOps is very important here. By the way, if you wanna make questions, just put your question there. I can stop. I'm monitoring the comments here. I'm happy to go any question during the session as well. GitOps is, like I always say, is a way where we change the way that we're going to deploy. We're not going to be pushing the deployment like kubectl apply and apply YAML configurations to a cluster. That's how Kubernetes deploy things, using configuration files. In some stage, we created Helm, Customize, things just to create like a template on top of those YAML files. Helm is more than a template, but it's also a template. But now we're going to say the cluster is going to deploy the application himself. Then the Git source is the source of truth for your application. Then you get those YAML files, those Helm charts. You push them in a Git repository, and you're going to configure, your cluster to go and look for that configuration. And you're going to be watching, monitoring those configurations. Every time that someone merges something, you're going to look at a specific branch. You can configure that the way that you want. They're going to get that configuration. They're going to apply to the cluster. Okay, then that agent running in your cluster now is deploying your application. You don't need a separate agent from a pipeline to do that. And that's a game changer. And how that works, if you go a little bit deeper, is like that. Azure Arc, what do we do? The first thing we do, we get clusters, AKS, even AKS, by the way, any cluster that you create on Azure, there is no cost or any, associated to use Azure Arc. And AKS, even self-managed clusters that you're going to see here using Cluster API, you don't pay for that. But you can get those clusters running anywhere. You can connect with Azure Arc, number 2 here. And the number 1 is exactly the problem that we're going to discuss next, is how to create those clusters and how Cluster API can help us to create those clusters. But assuming that the clusters are created, we join the number 2 here, we join the clusters on Azure Arc. We apply GitOps configurations. Okay, once those configurations are applied, on that configuration, we're going to point for that Git repository where your YAML or Helm charts are. And from there, that, what you call Flux operator that come from Weaveworks, that pretty much created the concept of GitOps the way that we explaining here. And every time that someone changed that YAML file, that Helm chart, they're going to be watching that and picking the change and apply to your cluster. Then V1 comes, once someone change, V2 will be deployed, and it'll be using the native Kubernetes, rolling deployment, blue-green deployment. And that's how it works. Now you don't need a pipeline to be pushing, it will be pulling. Okay, we're changing from push to pulling. And then how Class API, now going to Class API, how Class API can help on that. Think about Class API. Okay, Class API is a project inside the Kubernetes project. As probably you know, Kubernetes was donated to one thing called Cloud Native Compute Foundation. That's a cloud native foundation to manage all those projects related to cloud native, to containers, to Kubernetes. And Kubernetes is the main one. But there is always what they call the SIG projects related to Kubernetes, and Class API is one of those features that is still in alpha, is going to beta. Then that's the right time to to join and follow. You can follow on Slack channel, on Kubernetes Slack channel. There's a Class API for Azure. And how that works, they created one, let's call this control plane, okay? But they call management cluster, where all these things here on top, they call custom resource. All those things are your control plane. It's the Class API management cluster. And now we have kind of, if you watch that movie Inception, where you have one word inside another, that's where we are here. Class API itself, they deploy using Kubernetes. Means that we're going to use Kubernetes to deploy, to create all the Kubernetes clusters. I have a piece of control plane of management that runs on Kubernetes, and from there I can manage it, and I can create all those target clusters here that we call workload clusters. And those workload clusters that we're going to create using that control plane, that management cluster, could be anywhere. Why? Because they have one thing called providers. And each cloud or each technology, they create their own provider following the same configurations like machine deploy, machine sets. Those things here that you see are the all customer resource definitions on Kubernetes. Customer resource definition, nothing more than a YAML file, like a schema, where you apply those configuration, okay, to a Kubernetes cluster. It's just pretty much passing configuration for someone. Say, look, I give you this YAML file, telling everything that I need to create a cluster for me. How many machines I want, how many control planes I want, how many worker nodes I want on my cluster. And they're going to get all those YAML configuration files, and they're going to apply and create those clusters for us. But we need Kubernetes for that, okay? We need that management cluster to be running to be able to go and creating clusters anywhere. And that's why we're going to use AKS, because AKS is a fully managed service. I don't want to care about this because that will be a single cluster that I have to create just once, where I'm going to install Cluster API, the core. That's what you see here on top. It'll be all the agents, all the CRDs. And from that AKS cluster that we're going to see here probably on the demos, that diagram shows what we're trying to do. We're going to create this AKS cluster, and that will be our control plane, our management cluster. And from there, we're going to use that, what you call CapZ, that's the Azure provider for Class API. And you're going to create all the clusters, self-managed clusters. You can create fully managed if you want as well. And now we're going to apply Azure Arc. We're going to connect those clusters to Azure Arc. Okay. And we're going to apply GitOps with Flux. And you're going to see that working. Sounds good? I think that's a good, before the demo, if someone want to ask something, I think that's the right moment. Let's see if makes sense going forward. Okay. I'm going to get my browser here now. Give 1 second. Looks like I don't have any question, but let's go for my browser is not coming through. Let's just minimize a little bit here. There you go. Yep. Now I have my browser here. We have also going to bring here my Visual Studio Code. Okay, if you want to follow that demo, what I'm going to use here, I'm going to use my browser. I'm going to use Visual Studio Code, pretty much that. There is one thing called Class API book. You can also follow to create, to follow what we're going to do here. And soon I'm going to commit. I haven't pushed the code here, but there's a Git repo that we're going to share here. Okay. First thing first, let me go on the source groups. Scroll, maybe grow a little bit the zoom here. Scroll up. I created that control plane in advance. What's that control plane? That's just like a AKS cluster. You can create this cluster. I'm going to give you the script to create, but you can create on Azure Portal as well. And I also joined this cluster on Azure Arc. That will be my management cluster. And if you remember from the presentation, that's on top here. That's the management cluster here on top. That's done how AKS deploy a cluster. If you never saw AKS before, AKS creates all the resources here, where you have manage identity, scale sets, okay, and load balancer. That's the AKS cluster. If you go on this cluster itself, you can see once you create a cluster, you can also get a way to connect the cluster. You just getting credentials, pretty much that command here. And that's what I have done. And let me get my command line here. If I go kubectl config get context, you can see I have kept control plane there. How I did that? I just run this command here. I just run that. Okay, not going to run again. And once I do kubectl get nodes, I have my cluster running. Then if I go to see everything that's running on this cluster, let's go here. You're going to see that I'm also applying the probably get only getting pod, you can see I'm running Gatekeeper, where you can apply policies. That's Open Policy Agent. We're using the CapZ system, means that I have my management cluster running here. I'm going to show how I did that. And I also have Azure Arc enable. I enable even if it's a AKS, I can join Azure Arc. And I now have Azure Arc here. I have Flux operator running. That's Flux v1. Flux v2 is coming, is in private preview at the moment. If you want to join the private preview for Flux v2, let us know. And pretty much we have the components running on the cluster. If you want to use Azure Portal, you can also use Azure Portal to see those things. Now we can see workloads here. And you go in pods or you go in deployments, and you can see everything that's running there. Also by namespace, looks like Azure Arc is still pending. Maybe it didn't work properly my join here. I missed something. But anyway, that's how fully managed AKS cluster works. And why I'm using AKS for that? Because I need that management cluster that's going to create just once. And the way that I created, I use just command line. Okay, I'm going to maybe do like a preview here. I'm going to push that for the Git repo. Yep, probably better like that. You can see that I'm using AZ, that's Azure CLI AKS create. And I'm using like a existing workspace for logs, for log analytics. I'm also using, attaching that for Azure Container Registry, existing one. I'm enabling a specific Azure Active Directory group to be the admin group. You have to create this group before. Otherwise, you're not going to able like Active Directory, at least for administration. You need the admin group. And you just have to do that to enable Active Directory for AKS. Running this command, I create that cluster. I create the resource group first. I create the cluster that you guys just saw. And I had to install some things. To work with Cluster API, I have to install that cluster CTL. That's a command line tool to manage cluster CTL, to manage a cluster API. And you can see how we can install that. The same thing on Azure, you can install like kubectl if you don't have it on your machine. By the way, I'm using here Windows Subsystem for Linux. They call WSL2. It's a very lightweight Linux. That's on my Windows 11. I'm using Windows 11 here already. And I have just a Ubuntu 2004 where you can run those commands and install if you don't have. Also to get the credential for like I was showing before. And now I have a control plane running where I have to install what we call, those components from Cluster API. I have the AKS cluster, but I haven't installed those components yet. Okay, and then if you go on the Cluster API documentation, on that quick start, you're going to see here they're not using AKS, they're using a local Kubernetes cluster called Kind. We're using AKS. They're installing the cluster CTL. You can see here. And now they have cluster CTL init to initialize, this cluster. To initialize a cluster to work with the Azure provider, okay, there is one thing you can do. You can run just like cluster CTL init. They're going to get your kubectl config file, the kubectl that you have in your bash, and they're going to apply that for the cluster. Okay, ClassCTL is just getting a bunch of YAML file and creating that for you. But if you want to also install the provider, because you're not going to use ClassCTL by itself, you need a provider. In our case, I'm installing the Azure provider. Okay, there are instructions here how to install the Azure provider. Then you have to say that, not just cluster init, but cluster init infrastructure Azure. Once you do that, you're going to install the required components inside your AKS. That will be our dashboard, our management cluster. They're going to install all the class API components there. Once they do that, we now can create what they call workload clusters. To simplify, okay, there is one thing called Azure Arc Jumpstart, where they created some scripts. You can get this Git repo where there is an option for class API. I just got this one and I put inside my repo there, but coming from Jumpstart. It's a small change. What's that? It's just a script to do pretty much what the web page was explaining for us there. We can do here. That script is going to get those information from us, the size of the machines that we want to create, how many nodes we want to create, the location, okay, the version of the class API that you're going to use, the Azure provider one, and the class API itself. They're going to do pretty much what's on that web page. And if you look here, they're going to do an initialization for us. There's a big initialization here. So a little bit bigger here, maybe. Yep. Sounds better now. That command here, class init, that's pretty much doing the same thing there, but it's also setting the version. Okay, that will be that 052 here. And that's what we want to do it. And I have done that on the AKS cluster already. And that script is going to try to do again, that's fine. They're just going to do a reconciliation on what's already done. Because we're going to deploy the same version. Then it's not going to change anything. And after that, they're going to try to create one workload cluster. What's a workload cluster? That's exactly what we're trying to do here. We're trying to create those clusters that are spread across the globe here. We wanted to create those clusters. And those clusters could be anywhere. In our case, we're going to create one cluster on Azure itself, but it's not AKS. It's a fully managed cluster. It's a self-managed cluster. It's fully managed as AKS. Then we create a self-managed cluster. Okay. When you create a cluster with class API, is a self. Just to show one cluster I did create already before we go for the command line. If I go here. I created a couple of clusters for us. And we have those clusters running. And as you can see, that's not an AKS cluster. That's self-managed cluster where you can see the virtual machines. You can see the virtual network. And I also joined that to Azure Arc. Because as you can see, the script is also joining that. At the end here, the script is going to do the whole thing. And at the end, they're going to connect this cluster to Azure Arc for us. And if I go back there, I can click here on Azure Arc. Now I can see that cluster created by Cluster API. That's a self-managed cluster running on Azure, attached, connected to Azure Arc, where I can do things like monitoring. This cluster could be on premise using another provider. I'm just using Cluster API Azure provider to create a self-managed cluster. Why we do that? In Azure, I recommend using AKS. You can use in Cluster API to create AKS clusters as well. But if you want to do customizations on your cluster, you want to do more, security restrictions or anything that you want to change or customize the nodes, you can do with Cluster API and a self-managed cluster. People using one thing called AKS Engine before. Before AKS, Microsoft had one thing called AKS Engine that was a way to create ARM templates and deploy a self-managed cluster. There are a lot of customers using that, and Cluster API is an evolution of that. What's the main advantage of Cluster API is once this cluster is connected here, that's more like Azure Arc, benefit. But you can now manage the day two operations of those clusters. Means now I can go back on my configuration for this cluster. That's here, like say Azure Reactor 1. That's a YAML file, like I would say, is just a YAML file. And I could just change something here. Let's say worker nodes, control plane. Okay, that's like Kubernetes CRDs for Cluster API. Machine deployment. See, size of the VMs. That's it. 260 lines of code, you deploy one Kubernetes cluster with that single configuration here. If I get that configuration and I set it like a GitOps, you can use GitOps as well for the management clusters. Means every time that I push like one replica here, that's going to deploy a second node on my cluster. The same for the control plane, replicas 1. I can change, update Kubernetes versions as well. Now I can, only using code, using YAML file, using GitOps, I can also manage my clusters. And now I say, Jorge, can I do that for the applications as well? Yes, you can. With Azure Arc, what I did here, I create another folder called workloads, where I put like an application YAML file. I'm just deploying a simple Azure Vault application. That is like a Redis cache in a front end. And I deploy those applications on those clusters using GitOps. And the only thing you have to do is going on the Azure portal. If you go on the GitOps configuration, I apply that configuration here. I apply that details. The only thing I said is get from my Git repo, that one, inside a specific folder, that be workloads, on the main branch. And that agent is a Flux that's running on your cluster and is looking for the Git repo. Anytime that you commit some change on that YAML file, that's your application, they're going to redeploy for you. And that's how GitOps works. You can also run these on command line. You can also do configuration here, and that's how I did. That's the configuration to create a GitOps configuration in Azure connected cluster that could be running anywhere. If I open my terminal, Cluster API demos, probably need one here. Let me try to do just one for us to understand how that works. Yep. See here, I have my init file. Only thing I'm going to do is I'm going to create another one. Okay. Let's say I'm going to create number 3. The same size on the same region. I have set those information here on my bash file, bash rc. Then I go if I run that, they're going to create, that script is going through all that steps that's on the documentation. Like I said, they're going to try to initialize again. That's fine. It's already initialized, the management cluster. By the way, you don't have to do that all the time. You could remove that or comment out the second time. But then you're going to use cluster.ctl to generate those YAML, Azure Reactor 1 YAML file was created by this command here. Then what that means that the way that we create the clusters, we don't have to know all that YAML files and CRDs. Cluster API team created a lot of templates, and that's the repo for Cluster API Azure provided. You can see the templates here. Inside the templates folder, you're going to see a lot of templates that can be used there. Then on that command, generate cluster, you could use any of those templates. There's a dash from here that could be set. We're just using the default template. That's the cluster template. But we could be using any of those templates here. And each of those templates require like different variables, like those those variables here that you have to pass for those templates. Then that command just generates the YAML file. That's your cluster. Okay, then now you can get this YAML file using GitOps and keep maintaining this YAML file to do like day two operations of your clusters. It'll be one YAML file for each cluster, and you can build those YAML files using templates. That's very flexible to create those configurations. You don't have to understand very deeply. You can use the templates for that and just pass those variables. We're just using one default here. We're going to see those clusters to be created some stage here. Let me close. If I refresh, let's see if that's working. Running from here. Let's try again here. My script needs some see if any question. I think I comment out something on my script. I can fix and put it there on and push to the Git repo for you guys to give a go. Let me go for my slide. We're getting close to the end. And please, if you want to ask something, that's the time. Just to do a review, what we're doing here, we created like a AKS cluster. We enable the management cluster API control, the control plane, using that Azure provider. And from there, we created those clusters and we enable Azure Arc and GitOps configuration to deploy also applications on those clusters. And now, every time that I commit anything for my, there's time for questions. Anytime that I commit anything for my cluster, that's going to be applied automatically for those classes. Means if I go on that, if I go on that Azure Vault application here, replicas 3, okay, then let me push my changes. If you have questions, I'm going to keep here this extra. Just going to remove those. Only thing I want to commit to that one. Yep. Scale up. Let's do a scale. Let's push that to the Git repo. See if my push works. And let's go back to the cluster. If I go back to any of those classes, by the way, I have you can use the insights as well. But the best way probably is a way to get these is there's a little command here. I have the kube config for that cluster. Yeah, you see that now I have 3 copies of the vault, right? 3 pods. And that's how I see that was scaled. And the same thing for the other cluster. If I go on the cluster 1, that I also have the config file here to connect. Probably not here on this folder. Okay. More. Let me take this. There you go. Should also see 3 cops. Yep. You see 2 minutes ago. The same for the other one. 75 minutes ago. Means that once I push my commit, both classes automatically got the change and redeploy the application. Those both classes now have scaled the application using the GitOps integration that we just showed. I think that's pretty much that. There's a lot of things that we can go that, maybe another session, a little more deeper. I shared that on my slide share. There's a lot of links there. Probably go for my slide share. Sarah, if you are there.
Hi, George. Yes, I'm here, thank you. Did you answer that question earlier that was from someone, I think it was Andres from Learn TV. He was watching it on that platform. He asked, how do we manage the CAPI cluster with a different cluster?
With a different cluster. Yeah, it's a good question. You don't have to use AKS to manage those classes, to be the management cluster. You can use, for example, any Kubernetes cluster you can use. On the documentation, you can use kind or Docker desktop or Rancher desktop. Say I have Rancher desktop, I have Docker desktop here as well. Any Kubernetes cluster you can use, but keep in mind that that's your control plane now. You want to be safe. I'm trying to show not just like a hello world here. I'm going to show, keep that cluster somewhere safe. But just for testing, go for kind. And the jumpstart documentation that I have the link here, they point for that as well. That's the jumpstart documentation is using kind. That one. You there?
Hello, sorry, George, I wasn't sure if you were done. So thank you very much.
That's the link. That's the link for what I say. And here they using kind. That's another. But yeah, you can use any Kubernetes cluster. That's pretty much the answer. Thanks a lot. Appreciate everyone that's watching, and keep following that. Keep following the Azure Arc with more videos as well.
Thanks, George. So all those links that George just referenced to in his presentation are available via the check-in link with the event code 14269. We've also put in there a couple of links to our upcoming events on the Sydney Meetup page and also the Reactor YouTube channel. So if there's anything you missed from today, there's the on-demand version available straight after this, and also the link to the survey with the same event code 14269. Otherwise, George, you can go and enjoy your lunch, and to everyone else, wherever you've joined us from today, have a good rest of your afternoon, evening, or morning, and we'll see you next time for another Microsoft Reactor live stream event. Thanks, George. Thanks, everyone.
Thank you, everyone. Thanks, Sarah. Appreciate it. Bye, everyone.